Good morning, students. Myself Balwant Patil, Faculty Department of Electrical and Electronics. We supposed to discuss today the topic named transistor or transistor applications, which is a part of unit number 4, the second chapter into it. We have already discussed about the basics of a diode and the diode applications. As far as the transistor is concerned, it is a 3-terminal device, and specifically when we talk about BKP, we have terminals called as collector, emitter and a base. It can be observed in the form of diodes. So we got 2 diodes connected back to back. So P regions, both the P regions are forming a one node. We call that as a base. This PN junction we have, and we can have an emitter terminal, and we got a collector terminal. When we want to see the structure of the device, we have a base region, which is the thinnest layer out of the 3 layers. We got a collector, which is in terms of area is the largest one. So we can have a comparison on collector and emitter. When we compare these two, the area of collector is more compared to emitter, and emitter is very much electron rich. More number of electrons are present in this particular region even compared to collector. In a P region, here base, we have number of holes, but when we compare the count of charge carriers is the largest in emitter, and in a base we have a least count. Okay, in detail we'll be discussing the application of a transistor as an amplifier, but for now there is a necessity. When we want to use a transistor as an amplifier, we want base to emitter terminal to go forward and base to collector to go reverse, to remain reverse, irrespective of input variations that we can observe here. So this is a base region and emitter, and this therefore should go forward, and this diode junction or this PN junction should remain in a reverse. So we can understand this is forming a low resistance part of the resistance, and this is forming a high resistance. This discussion is if we want to give the basic definition of a transistor, the word transistor gives the presence of 2 terms. One is a transfer and one more is a resistor. This is basically associated with transferring a signal from one resistance level to another resistance level, and therefore we have a second term called as a resistor. Generally we define the transistor as transferring a small signal from a low resistance to high resistance circuit. As far as the types are concerned, there are 2 types. One is a NPN transistor and one more is a PNP. A symbolic representation, you can see the difference. As far as the emitter is concerned, the arrowhead which is indicating the direction of the current. In this case it is outwards, and in case of PNP it is into the device. At a broader level, when we see the applications of transistor, we got applications called as amplifiers. Then we have a switching applications and can be used in oscillators also. In oscillators to generate the signal. As far as the amplifiers are concerned, we call them as a linear applications. The reason is the output is always the function of the input. The input and output both are sinusoidal, and output always remain to be a function of an input. So there is a dependency. This phase shift may be there, or in some configurations we can have no phase shift of the output with respect to input. As far as the switching applications are concerned, the output switches between the fixed states, fixed values of the output. VSAT indicates the saturated value, the maximum value of the voltage. When BJT is to be used for the purpose of amplification, the necessary conditions are the base to emitter should remain in a forward and base to collector should remain in a reverse bias condition. When we operate the device for such configuration, we call the device is operating in a operating region or in a active region. Basically, a device can be operated in a three regions called as saturation region, cutoff region, and the active region. As far as the application called amplifier is concerned, the device has to be operated in a active region. To keep the device in operating region at primary level, we can use two DC batteries. In this case, we have two batteries indicated as VB and VCB. In a practical usage, we do this arrangement using only one battery and the resistors. But to understand the concept why it is necessary, now we go with the two batteries, and you can observe that we are applying positive potential at a base with respect to emitter. In other ways, we can say the DC potential applied at a base is more compared to emitter, and therefore this particular junction, the base voltage is more than emitter, and therefore this will go forward bias. With this particular arrangement, what would happen is the number of electrons present here will be pushed, or we can say those will be pulled into the base. But for the reconfiguration process to happen, we have a limited number of holes. We can take an example, something like we have 100 number of electrons present in an emitter and we have only 10 holes. So because electrons are pushed, will be captured, or the reconfiguration process takes place in presence of only 10 holes, and this particular is going to form the base current. So base current is formed due to limited number of charge carriers here, and therefore the base current is very small. More number of electrons now have a tendency to jump into the collector, and collector, this particular battery arrangement gives a favorable condition. You can observe that the more positive potential is applied, and therefore it will ask for the electrons, and therefore these extra electrons which are remaining after the recombination process will try to jump into this region, collector, and therefore this region we call as a collector. The more positive force applied at the collector region will draw the electrons and create the number of holes, and therefore the excited electrons from emitter will jump into the collector, and there are the holes present due to this positive potential, which will form the current in this particular region. We call that as a collector current. So the collector current is again going to be a larger current because this is out of these extra electrons which are larger in a number.